Hello, my chemistry faithful. Video 6, electrochemical cells. That is an overarching word. We're going to get specifically probably into voltaic cells in this particular video. So, identify the parts and functions within an electrochemical cell as it produces electricity, not if. A chemical reaction. I can state the direction of the flow of electrons from anode to cathode or cathode to anode. That's a given every time. So, voltaic and electrolytic cells, they are electrochemical cells. We're going to deal specifically with voltaics, mostly this particular video, because that's the most important part. Okay, voltaic is a spontaneous reaction that turns stored chemical energy into electrical energy. Okay, good. An electrolytic is a non-spontaneous reaction that needs electricity to make it go. Keep wondering if I got it right during the definition portion of the unit, but it's really here nor there. This is really the difference. So voltaics go spontaneously. Electrolytics need electricity. If we call it use electricity to store chemical energy or to make more electricity, neither here nor there. You can electroplate with that stuff, which is fun, and Monica's got that. I don't have that. Okay, electrodes are the metal pieces that go in to set this thing up. So as the metal connects the solution to the cell, the oxidation number is always 0 because it is a whole metal. Hence, if you look in the picture, I have one's an Mg solid electrode, the other is a copper solid electrode. If I were to see copper and magnesium in the reaction underneath, notice that I would assign those as zeros. Okay, so it always starts at 0. The anode is the positive electrode where oxidation takes place. Okay, oxidation is losing electrons. I lose an electron, what's left? I'm positive now. Okay. The cathode is the negative electrode where reduction takes place. Reduction is gaining. Oil rig, gain electrons, I become more negative. Okay, good. Direction of electron flow. This is for voltaic cells specifically. They always go from A to C, anode to cathode. So you figure out who the anode is, you figure out who the cathode is. Now you know which direction it's going. And this is not through the salt bridge. This is up through that voltmeter. Which way are they going? Okay. The salt bridge just lets ions flow, completing the circuit. All you have to say is allow ions to flow, and you have complete credit. Okay. You don't have to explain more than that. They just allow ions to flow, and hence they do complete the circuit. If the ions get stuck over here and can't go to the other place, then the whole cycle gets broken. So it also does complete the circuit. But what does it do to complete the circuit? It allows those ions to flow. So they mean the same thing. Okay, so stepping to the board and using an actual voltaic cell to come up with these half reactions. So I see the reaction underneath, okay? And that's what's going on here. So I have Mg0 plus Cu plus 2 goes to Mg plus 2 plus Cu with the 0. Now I'm pulling that right out of the bottom of the picture, okay? And I don't think there's any more. Yeah, see, there's no more. So I got to do this now. So I got Mg going from 0 to plus 2. I need to write down oil rig, right? And 0 to plus 2. Plus 2 means more protons, so I must have lost electrons. So lost electrons is oxidation. See, oxidation is losing. I need to do this. MgO is going to go to Mg plus 2. He's losing 2 electrons. Okay, so I'm going to do this other part last. Oh, I guess I can do it because it's going to be right. The reducing agent is the thing that's being oxidized, so that's Mg0. And the number of moles of electrons involved is 2, so I'm done there. Okay, so now I'm going to switch colors and go to Cu plus 2 goes to Cu0. Why did I write C0? Probably because I said Cu0. See how I jumped the gun there? Cu with a 0. And how many electrons do I need to get from a 2 to a 0? I need 2 electrons. So we're good there. The oxidizing agent is the thing that's being reduced. Cu plus 2, how many moles of electrons? 2 moles of electrons. And there we got that. So this is applying those half reactions to the actual cell itself. Okay. And then we are done, I think. All right. So let's just talk a little bit about this picture and what's going on and to further explain it because we have a little bit of time. So I have this Mg0, right? And so the electrons are going to go from Mg0 and Mg plus 2 is lost electrons. So when the Mg atom here loses 2 electrons, they go this way. So 2 electrons go this way. And then this is where the Mg2 falls off into solution when that happens. The electrons go over here because I got red cat, angry ox, okay? And losing electrons, oil rig, is ox. So this is the anode because the oxidation happened here. And so I know it goes from anode to cathode. So therefore this is the cathode. And I got the Cu0 here, 2 electrons coming. And it's going to, on here, make a Cu. That shouldn't be a +2, now should it? In the picture, it should be a -2. Yeah. Oh, I see what's going on. Because the electrons go right through. Okay? Because the electrons go right through. Mg over Cu. Let me just double check this, because Mg should be above Cu on the chart. And oh, yep, it is. Mg is more reactive, so it loses. So, yeah, how do we fix that +2? Lost 2 electrons, it goes into solution that way. Yeah, this is how it works. That's how it works. So, this is what's going on. You'll see a voltmeter. That V, that's telling you it's a voltaic cell. How's that? Does that help? And I always go from anode to cathode. So that's really kind of what's going on in this particular thing. And if we do lab, we can set this thing up and change out these electrodes and see which one makes more energy. And I'm guessing it's going to be the one that's higher on table J. And with that being said, we're done. Oh, bang, bang. Press the button and the video's over.